Okay, welcome back, 11s and 12s. We're going to go through the two more reaction types in this lecture, reaction types 2 and 3, which are synthesis and decomposition. So last week we went over combustion, and I'll recap that. And then the next thing we're going to be going over is the rest of the reaction types. All right, so just recall combustion is what we went over last week. So combustion reactions normally involve oxygen reacting with a carbon and hydrogen-based compound to create CO2 and H2O, and that's if you have clean combustion. Okay, so the telltale sign that you have a combustion reaction is one, you look over and you see, oh, I've got O2. That's an indicator, and then you look over at the other thing and see, oh, is this thing loaded full of carbons and hydrogens? It is. We can even go further and say, oh, what are the products? Oh, they're all CO2 and water. Then for sure, that's a combustion reaction. Okay. Now that's clean combustion, okay? Because we know that there's clean and dirty combustion. So clean combustion is blue flames. When you see blue flames, that means clean, nice combustion, producing only CO2 and H2O. And then if you see the yellow flames usually indicates that you're going to have some carbon monoxide, some pure carbon. You're also usually producing smoke at that point. Okay, if you have a blue flame, you shouldn't have any smoke. Now, most fires are going to be yellow. They're going to be dirty flames because it takes an apparatus. It takes a level of control to make sure that it burns perfectly like a blue flame. So you need something like a Bunsen burner or a furnace or an oven. Okay, if you just light a fire, any kind of natural fire is all going to be incomplete. Okay, depending on what you're burning. If you burn something like ethanol, sometimes you can just light ethanol and it'll still burn clean. But most things like paper or wood, it's going to burn dirty. Okay, I just had something happen to me over the weekend, and it related to combustion, so I thought I'd bring it up. It's the idea of what's called the backdraft effect. Okay, so when we look at the combustion of fire, you can see that in order for fire to happen, we need to have oxygen. Okay, it's a major part. So fire really looks for oxygen, and that's how we can put out fires is by starving it with oxygen, and that's really what a fire extinguisher does. So a fire extinguisher is just CO2. It's just liquid CO2, and when you spray CO2 on a fire, it basically eliminates the oxygen, and if you don't have the oxygen, it puts out the fire. Same with if you use a fire blanket. Okay, when you put a fire blanket on top of, say, something burning, you're basically eliminating the oxygen. It's one of the main ways that we put out fires. Okay, when we use water to put out a fire, we're just basically covering whatever the fuel is in water, and then oxygen can't reach the fuel, so it puts out the fire. Okay, so that's why things like water put out fire. Now, the main thing that I want to get across here is that fires love oxygen, and it searches for it. So what happened to me over the weekend was I actually burned off part of my eyebrows and my eyelashes. And this is what happened. Basically, I had a barbecue going, and inside my barbecue, I could see there was a fire that had happened. Some grease had dripped down and started a fire. So these yellow flames inside my barbecue, it's burning incompletely. Right? And as it's burning, it's just eating up all the oxygen that's inside that barbecue. Now, it's not a sealed case, but it ate up a bunch of the oxygen that was inside there. So what I did was I wasn't thinking, and I went over there and I opened up my barbecue. Well, when I opened up the barbecue lid, what I allowed was a whole bunch of oxygen to now rush in. And as that oxygen rushed in, as I opened up the lid and gave the fire fresh air, the flames followed the oxygen out of the barbecue and then up out of the barbecue and anywhere that was around my face and singed my eyelashes and eyebrows off. Okay, so this is kind of what's known as called the backdraft effect, and it's one of the reasons why firefighters have to be very careful and trained and know how to fight a fire. Because sometimes when people are in a house fire, they'll say knock out a window or kick out a window, and what that will actually do is set a huge fireball throughout their house because they've brought in a lot of oxygen. Okay, now if you are in a fire and you need to get out, kick out a window. It's always better to be safe for sorry, but just knowing there is these things called backdraft effects. Okay, and if you're interested, you can look it up. Okay, getting into the reaction types today, synthesis reactions. So in synthesis reactions, they all involve making or synthesizing something. To synthesize something, it's another word for making something. Okay, so we're going to make stuff from smaller building blocks. So it involves taking simple molecules or atoms and then combining them together to make something more complex. And the basic idea is you take something simple like A, something simple like B, and then you get a product where they combine together like AB. Right? Now, in this course, the only ones that we're going to focus on is when you have two elements that come together to form a compound, okay? Or the other one is when you have an element and then a compound to make something more complex. Okay? So let's go through a couple examples here. Okay, the first one we're going to go through is an element plus an element leads to a compound. So examples of synthesis reactions here would be things like if I take carbon and I add hydrogen, I'm going to make something like CH4. Okay. Now, this is not something that we would normally ask you to make, though, and the reason for it is this is covalent. And to know that formula, that it's CH4, is difficult because we could use the crisscross rule, and it actually works in this case. But with covalence, it's not always the case. So in almost all the reactions that we do are all going to be ionic. So I'll give you an example of ones that we would be specifically doing. Okay, so we take an element, something like, I take sodium, and I add chlorine gas. So an element plus an element, so that's an element, leads to NaCl. Okay. Now, what I don't want to forget is when I made my formula for NaCl, it comes naturally to us because we've done it so many times, but we have to remember the crisscross rule. Okay? And these went down here, and that's how we got that formula of NaCl. Because whenever you form something or predict a product, you have to use the crisscross rule. Okay? So that's an example of a synthesis reaction. An element plus an element making a compound. Okay? Now, let's go through one where it's an element plus a compound. Right? So an example would be something like, say I take sodium and I add a nitrate. Right? So this is a polyatomic. Okay? And remember, these are just, we always put brackets around them to make them easier, and they'll be on the back side of your periodic table. So if we want to combine these, and there's going to be a reaction that happens, okay, we're going to have to use the crisscross rule. I'm going to just do it right down here so it doesn't get messy. So Na is plus 1, NO3 is minus 1. I do my crisscross, and I get Na, NO3. Okay? And that's an example of a synthesis reaction where you had an element plus a compound. Now, the compound are always going to be polyatomics in these cases. So an element plus a polyatomic compound leads to a compound. Okay, now, those are synthesis reactions. Okay, the exact opposite of a synthesis reaction is a decomposition reaction. And that's the other reaction we're going to go through in this lecture. So decomposition reactions all involve breaking something down into simpler atoms and molecules. Synthesis, the ones we just did, created something. Now decomposition is the opposite. It's going to break it down. So it involves taking a complex molecule. Okay, so we're going to take a complex molecule, and we're going to break it down into simpler molecules or atoms. We're basically going to do the reverse of a synthesis reaction. And if you look at the basic idea, it is the reverse. You're taking something like AB, and then you're going to break it into two pieces, A plus B. Okay? So in this course, it's going to be the same kind of thing, the opposite of the synthesis. You're going to take a compound, which is then going to be broken into an element plus an element, or you're going to take a compound and break it into an element and another compound. Okay? So let's take a look at some of these examples. These are going to be very similar to the ones we did before. So the first example we'll go through here is a compound going into an element and an element. Okay? So an example of this would be something like NaCl, and it gets broken into Na plus Cl. Now I made a big mistake here. Okay, this is very, very common, so you shouldn't feel bad about making this mistake. It's very common. So see if you can identify what's wrong with this reaction right now. Okay. And I'm hoping that you identify that there should be a 2 there. Okay, because remember, chlorine, whenever it's by itself, has to be in a 2. So this is an example of a decomposition reaction. We had a compound, NaCl, being broken into an element and an element. Okay. All right, now let's take a look at an example of a more complex compound breaking. So another example. So now let's take a something like Mg SO4. Okay. So we've got MgSO4. There's my compound. And if we were to break it apart, right, this would go into Mg. Okay? I don't need to put a 2 because it's not a diatomic, plus SO4. Okay? Now, what I don't want to see is, I'm going to give you another example here, because there is another common mistake that people sometimes make. So let's do an example like this. If I had something like MgOH2, okay? Again, I did the crisscross rule, and that's why there's a 2 down there, because Mg has a 2 plus. If I break this apart, this is going to be broken into Mg plus OH, not OH2. Okay? Oh, that is only attached to the magnesium, but as soon as it breaks apart, you don't need that 2 anymore. Now, if we were to balance this properly, if we were to balance it, then I wouldn't put the 2 at the bottom, I would put the 2 here, saying that I have 2 OHs, but I don't leave it down there on the bottom. Okay? Just something to note. So we've gone through all the different reactions for this lecture anyways. It's just the 2, the synthesis and the decomposition. So I'd like to just kind of go through a couple examples to kind of summarize here. Okay, so this will be kind of our summarizing. So the synthesis of NaCl, that would just be Na plus Cl2, remember, because chlorine's by itself, and we're going to make NaCl. Remembering to do the crisscross rule, and that's why it's 1 to 1. Decomposition of NaCl, it's just NaCl leads to Na plus Cl2. Okay. Next one, synthesis of MgOH2, so this is going to be Mg plus OH leads to MgOH2. Okay, remember doing the crisscross rule. Mg has a 2 plus, OH has a 1 minus, so you crisscross as an MgOH2. And then the decomposition would just be MgOH2 into Mg plus OH. Okay? And if we want to balance them, we'll talk about balancing a little bit later. Right now, I just kind of want to focus on getting the actual reactions down, and then we'll focus on balancing. So that's it for the 2 types of different reactions in terms of this lecture, synthesis and decomposition. If you have any questions, let me know, and I'll be providing you a learning check to check your learning on this stuff tomorrow.